determine the force in members KJ, KD, and CD of the Pratt truss. State the members are tension or compression. So we want to find the force in these three members. So we don't need to know the force in all the joints, so we'll just use method of sections. So using method of sections, first we got to find the reactions on either side. We have G and the Y, and we got A and the Y, and A and the X, which is 0. So I'm going to go ahead and solve for G and the Y and cut it here and use the right half. So if I sum the moments about A, I get negative 20 times 2, negative 30 times 4, negative 40 times 6, and positive GY times 12 equals 0. Solving that, I get 400 equals 12 GY, and GY equals 33.3. So that's 33.3 right there. So let's cut it and redraw this side. So we do this. Here's J. And we got 33.3 here, and we got 40 kilonewtons there, and we have a force here, a force here, and a force there. Let's go ahead and guess that the force here at J will be going that direction. So now we have a new object with 3 unknowns, and we have 3 new equations. So let's start by summing. Here's D, and that's J, and this is G. Let's start by summing the moments about D. That eliminates these 2 forces and that one, and we can solve for the force here at J directly. So 30.33 causes counterclockwise rotation, so that's positive. And that distance there is 6. And then this causes a negative rotation, so Fj times the height 3. So Fj equals 66.7. So if we sum the forces in the Y, we have a vertical component here. So we get negative 40 plus 33.3 plus the force, let's call this F dk, force dk in the Y equals 0. So force dk in the Y equals 6.7. So looking at the ratio of the height to the width is 3 to 2. So if we do 3 over 2 equals 6.7 over F dk in the X, then F dk in the X equals 4.4. That's F dk in the X. And if we sum the forces in the X, we'll call this one FC, because it's pointing towards C. In the X we have 66.7, that's that one, minus 4.4 FDK in the X, minus FC equals 0. So FC equals 62.2, and that's kilonewtons.